Before we get there, let us first just answer and make sure you understand two of those terms that are very important conditions for equilibrium. First condition, you must have a closed system. What is a closed system? A closed system is simply one where the system is isolated from its surroundings. In other words, no matter can escape, like carbon dioxide, and no energy can escape into the environment. So it is isolated so that we can always just look and make sure all our gases and all our substances are still in the container. So that is the first definition you need to know. That's the first condition for equilibrium. Next condition, you must have a reversible reaction. You need to have a reversible reaction. What does that mean? It simply means if my forward reaction is nitrogen plus 3 moles of hydrogen, and that gives me ammonia, all I have to do then is to give a definition back, which is in my exam guideline. A reversible reaction is not only a forward reaction, but also a reverse reaction. How do I put it in words? The products, ammonia, can be converted back into reactants. So that means a reversible reaction is the normal one I know, but the reversible one, the products, ammonia, can also be converted back to the reactants. Right. Do you think you have those two definitions? Those are the two conditions under which chemical equilibrium can take place. What are they again? Closed system. Other one? Reversible reaction. Because I must have, at equilibrium, when the position of equilibrium comes to a standstill, then I must have reactants and products in the same container. Are you with me? So those are two conditions again. What are they? Closed system and a reversible reaction. Now, of course, it is important that we know exactly how this works with a given equation. I see here some more messages for me. I just want to go through it for you. Someone is asking, or Optimistic is asking, Udrend, I'm not sure what he's talking about. Someone says, I need a telematic book. Where can I buy it? Jason Pillay. Jason, if you're talking about the physical science book, you simply get it through your school, that is, through your teacher, your principal, deputy principal, from the curriculum advisor in your district. They should provide you with it. It's just a phone call away, no hassle. Your principal or someone must just make that phone call, and they will bring it to your school. There's another question here. Where can you find the examination guideline? There's a few ways. Your teachers have one, so you can make copies. Secondly, you can find it on a website on www.education.gov.za, or you can get it wherever, if you're in the Western Cape, WCED online, etc. So just Google it, and you will see Examination Guideline Physical Sciences 2014 guidelines. You can get it, but first, the teacher should be able to give it to you. If there are problems, they can ask the district to help to copy it for you. But this is your email from the examiner to you and tell you this is what we expect you to know in the examination. And it's a big help, I can tell you that, because I'm going to show you now how they use the exam guideline to set the assessments, to set the question for you. Okay, I think that's most of the questions. We are also with you now. Someone says a visitor here. Well, good afternoon to you. We are at Jamangele Secondary School. Well, all of you, I hope you are 10, 20, 30 of you, and that you really tuned in. Important thing is send answers. We gave the contact numbers earlier on. Now, let's go to the first question. Remember, the first part is chemical equilibrium, two terms, and the factors. And now I'm going to show you how the examiner has asked question 5.1 from that part of the exam guideline. Let's see. He gave you this equation in 5.1, and he says reactants 3x2, which is a gas, is in equilibrium with, look how I read that, is in equilibrium with 2 moles of the product X3, which is also a gas. So an unknown gas X2 is sealed in a container. Look here, closed system, sealed in a container to form the product X3. So what does this exactly mean? This means that I have a forward reaction, that becomes that becomes that, and I have a reverse reaction, that can become that. So 3x2 can also become, or 2x3 can also become 3x2. So that means I can read it that way and that way. Those are the two conditions. And then the question is, how will the rate of the formation of x3 compare to the rate of the formation of x2 at equilibrium? That is what they're asking. Write down only higher than, lower than, or equal to. So what they're asking is, well, that reaction, that rate of that forward reaction, how does that compare to that rate of reaction? At where? At equilibrium. Now watch this. From the exam guideline, I got this. Chemical equilibrium. It is a dynamic equilibrium when the rate of the forward reaction equals the rate of the reverse reaction. How will the rate of x3, where's x3? There. That means how will the rate of forward reaction compare to the rate of the formation of x2 compared to the rate of the x2 is the reverse reaction. You get that? So the rate is, if I get that for forward, so I get x3, that is reverse x2. You want to know how does it compare at equilibrium? What do we say? What does it say? The rate is equal. So which is higher than, lower than, or equal to? Answer, everybody. Come. Send through the answers. You got it. Let me see. Sir, start teaching already. Is this in the exam? I find it very hard to understand. I need help with it. Yes. And from Mandikosi, we've got a signal problem there at Mandikosi High School. Okay. Can I just speak to you for a minute? Yes, I hear that you've got a signal there at Mandikosi High School, and we are here, and it's an interesting lesson. Someone, the visitor, says, wow, thank you very much. But I can't be doing the work alone. You need to pass. You need to know the work. So guess answers, shout answers, write down answers, send in messages. I'm still struggling here to get onto the WhatsApp message because it's on the phone today. And you know, our older men are not so technologically inclined. So forgive me, I'll take a time, but I'll get there eventually and I'll find the messages came in via WhatsApp. I'm just reading off the SMS system at the moment. Let's get back to the work because you need to pass. That's important. My point is, the work that you are doing, the work that they ask you, comes from the exam guideline. Let's go quickly to my screen. Here we are. That is from the exam guideline. Here's the question. So, of course, what must you do? Go to the exam guideline, find the question. What is the answer now again? It's equal to, because I've got two ways to prove it. There it says in the exam guideline equal to, and here I have a symbol which shows me that the forward reaction is equal to the reverse reaction. It shows me the arrows have the same length, so it's an equal reaction. That's really what it is. And if I look at the graph of it, the graph shows there are the reactants decreasing, and that's the rate. Look there, it's the rate. Look at your graph, it's the rate. And here's the products coming up from zero, and the products, and what happens there? They are at the same rate. Make sure you understand this graph. Reactants decreasing rate, and the products increasing rate. X2 decreasing, X3 concentration increasing until the rates are equal. Wow, now I've got even more ways to prove it. There's equal, and two lines are running equal. Running what? I go to the y-axis, the rates are running equal. Wow, what an interesting way. Have I convinced you already? All definitions come from the exam guideline. You just need to know it. Now I've asked chemical equilibrium last year, so you've got one or two more definitions to learn under this section, and then you A for away. You will definitely you will definitely score good marks if you use your exam diagram.